We resume the lesson. Only a small part of this rotational motion theory is left out. We shall finish it now. Now here, we have learned moment of inertia. We have learned what is angular momentum and all these things. Now, there are very two important laws about the moment of inertia. One is called the law of parallel axis. Another is called the law of perpendicular axis. Say one is called the law of parallel axis and another is law of perpendicular axis. Right? This is number one and this is number two. We shall see these two laws now. Let us take first the law of parallel axis. Law of parallel axis, and we draw a line here to indicate the different lessons. Let's first try to find out the law of parallel axis. Let us take a body like this, say, a larger body we take for the sake of diagram. If I take a larger diagram, then it will be easy to explain what I mean to tell you. This is a larger diagram. Now, let us say this body is rotating around this point. Say this axis is like A, and say this is point B, and say this is say it is rotating around say ABC axis with a angular velocity omega. And let us say the body is rotating, the body is rotating around the axis with angular velocity, right? And let us say, and say moment of inertia around moment of inertia around axis A, B, C is equal to I. Right? Also say the center of mass of the body. Let us say center of mass of the body is here. This is the center of mass. The body is an irregular body. Its center of mass is here. Now, if we draw an axis through the center of mass, let us say this axis is D, say its center of mass is at O, and hypothetical axis through the center of mass is So this green axis is the axis if it is drawn through the center of mass, but the body is rotating around ABC with angular velocity omega. Now let us consider any point, say P. Let us consider any point P, which is any point P. Then what do we do? We also draw a line through O through B, O through B, line through O through B, and we take it as x-axis. And the vertical line through O, that means the vertical line or perpendicular line through the center of mass, we take it as the y-axis. And then let us say coordinate of P is xy. Coordinate of P is xy, right? In that case, if we draw a perpendicular from P to the x-axis, P to the x-axis, this is y, and the distance from O to this point is x. This is x because the coordinate of the point P is taken as xy, and we have drawn the x-axis through the center of mass through B and on the plane of the body, right? In that case, and say mass of the point P is mi. Mi. Any mi means there could be many such points. There could be P here, there could be Q here, there could be R here, there could be many such points. So mi, m1, m2, m3 it will come on. So let us say P is mi. Mass of the point P is mi. Then what is the moment of inertia? This I, moment of inertia I, around ABC, we have taken it as I. So, what is I? I is equal to I, let me do it this way. Moment of inertia of the point P, the point mass around the axis ABC, around axis ABC is, what is the moment of inertia of this point P around ABC? We know it is mass multiplied by this distance. It is the position distance. This is BP square. M. Is it clear to you or not? It should be clear. Because moment of inertia of a point is the mass of the point multiplied by its perpendicular distance from the axis of rotation, mBp square. Now, what is mBp square? We write mi because we have taken mi. So only writing mi every time is a little difficult. What is BP square? Y square. BP square is y square plus this distance is x minus, oh sorry, we forgot to take d. D is the distance between the axis passing through the center of mass and the axis around which the body is actually moving at this moment. So BP square, this BP square is y square plus this small distance square. This small distance is nothing but x minus d. This small distance is nothing but x minus d. So y square plus x minus d whole square. Right? So once we have done this, so this is the BP square. So this is equal to, let me write it here. This is equal to mi into mi into y square plus x square plus d square minus 2xd minus 2xd. This is equal to, or can we write it once again? This was I. So I is equal to then this thing. We take m inside the bracket, ami into y square plus ami into x square plus ami into d square minus 2dmix. This is equal to I. Now this is equal to, now mi multi y square, this is, okay, let me write it so that you don't miss any step. This is equal to y square plus x square plus mi d square minus 2d by x. This is equal to, now y square plus x square is the distance from the center of mass to P. So this is the distance OP. So x square plus h square equal to mi is equal to OP square plus ami d square minus 2d mi into x. This is the moment of inertia of the point. So to sum up all points moment of inertias. That means now we are trying to sum up the moment of inertias for P, Q, R, S, T, whatever. All points on the body, we take all of them and we sum up, and that is equal to I. This is I is equal to summation of mi and OP square. OP equal to R. This is equal to position vector. This is OP is equal to position vector R if we measured it from the center of mass, right? We note it here so that you don't forget. OP is actually R tends to center of mass. So instead of writing OP square, we write here AMI RI square plus sigma M D square minus sigma 2D MI X. This is equal to, now MIRI sig, what is MR square sigma? Sigma of MR square is actually the moment of inertia of the point around the axis passing through the center of mass, right? So, and we can write here like this, but sigma AMI RI square is actually moment of inertia of a body around the axis passing through the center of mass, through the center of mass. So, so this item is actually the moment of inertia whole of the whole body if it passes through the center of moment of inertia of the whole body if it passes through the center of mass. Let that be here. Moment of inertia of the whole body if it passes through the center of mass. And this is equal to, we designate it by the word I, by the letter I naught or I zero. That means moment of inertia of the body through a perpetual axis through the center of mass is I zero. And also, we have the second term, sigma AMI d square. Now, d is constant. It is the distance between the two axes. So, this is equal to d square and sigma mi. Sigma mi is a summation of all such masses. So, this is equal to capital M dis. I have a third item, which is sigma 2d mix. Since d is a constant, so we have to write it this way. Sigma 2d goes outside, 2d goes outside, 2d sigma mix. What is this item? 2d is a constant, so forget this. Sigma mix. X is the distance of the, is the abscess of the point from the axis passing through the center of mass. Right? If you remember the definition of center of mass, definition of center of mass is such that the sigma mixy for all masses is equal to 0. Because center of mass is the point at which all the masses can be considered to be concentrated at a single point. So this is equal to 0. This is equal to 0 since the center of mass. So what this relation turns out to be? So I put it this way. So find I is equal to I0 plus md square. This is the final way. That means moment of inertia of a body around any axis on perpendicular to it is equal to inertia through the center of mass plus the total mass multiplied by square of the distance, square of the perpendicular distance between the two axes. This is called the law of perpendicular axis. Now let us go to the next law. Next law is law of parallel axis. So this was, sorry, I'm very sorry. This was what we have discussed already. This is the law of parallel axis because the two axes are parallel here. And this one is actually the law of perpendicular axis. This is parallel axis. This is law of, now we are going to discuss law of perpendicular axis. We have already discussed law of parallel axis. Law of perpendicular axis is like this. Suppose you have a body. Suppose you have a body. Suppose you have a body and have you have drawn, and this is the axis of rotation, say. This is the axis of rotation. And you have any point P on the body which has a coordinate of xy. This point P has a coordinate of xy, and I have drawn the, this is x-axis and this is y-axis. That means the body is in the xy plane. This body is in the xy plane. In that case, this axis is the rotational axis, is the z-axis. If this point coordinate is xy, then this distance is x, this distance is x, and this distance is y. Right? Now we draw a parallel line here. For the sake of diagram, also draw the diagonal of this rectangular parallelogram. Now, this is the z-axis on which the body is rotating. If we consider the moment of inertia around z-axis, in fact, so long in the entire chapter, we have been considering the rotation around a perpendicular axis, which is z-axis. So, moment of inertia around z-axis, moment of inertia of the point around z-axis equal to summation of all mi, and if this point is O, is OP. Right? Now OP is OP square equal to x square plus y square. So this is summation of mi xi square plus summation of mi yi square. And this is equal to, so moment of inertia, we started with moment of inertia around z-axis, and we shall designate it as Iz. Automatically find Iz is equal to summation of Ix plus Iy. That means moment of inertia around z-axis is equal to summation of moment of inertia around x-axis plus moment of inertia around y-axis. If you draw the three axes in a different way, the same formula will appear again and again. That means Iz equal to Ix plus Iy. Similarly, there will be Ix equal to Iz plus Iy. Similarly, I y will be equal to I x plus I z. This theorem is called the law of perpendicular axis. I have only a little bit more left on this chapter. This kinetic, we have seen kinetic energy of linear motion. Kinetic energy of linear motion, we have seen linear, this part is over. Then what is the kinetic energy of rotation, of a rotating body? Since a body is rotating, definitely it has got a kinetic energy. It is in motion, kinetic energy of rotation. Kinetic energy of rotation. Now, if you consider any particle, consider any particle which is rotating, it's 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 it is like this. Say once again, there is a axis and there is a body which is rotating around this axis. If you take any particle p of mass m and it is rotating with a angular velocity omega. It is rotating with angular velocity omega, and say at any instant its linear tangential velocity v. Right? Then kinetic energy of this particle, kinetic energy of point mass, point mass is equal to V of m v square. Now v is equal to omega r, so it is equal to half m omega square r square. This is equal to this is equal to this is equal to half omega square, half omega square mr square, omega square mr square. This is the kinetic energy of the point mass. This point mass P. So total kinetic energy. So total kinetic energy will be the sum of all these things. So it will be sigma half omega square mr square over I. This is equal to half of omega square goes out because omega is the angular velocity and angular velocity is same for any point P, Q, R, S, any point that you think. For all of them, angular velocity is same. But there, mr are not same. So m r square. Now we find mr square is equal to the moment of inertia I, sigma mr square. So this is half I omega square. This is the kinetic energy. It is same as the equation half mv square, where mass is replaced by moment of inertia and v linear velocity is replaced by the angular velocity omega. This is one thing is over. Next thing we shall, these are some small issues, very small issues, but you need to remember them. What is the impulse? What is the impulse of a force? Now, if you remember in linear motion, although I have seen that in your textbook there is no numerical problem given based on impulse, but mind it, I have observed that in your competitive examinations, etc., there will be numerical problems or MCQs based on impulse. Impulse, if you go back to your textbook, will find when a force acts on a body for such a short time that its velocity, acceleration, etc., is not possible to measure. I'll give you a very good example. Suppose in a cricket game, a bowler he throws the ball and the batsman hits it. And that hit occurs for such a small time that it is not possible to measure the acceleration produced, etc., etc. In such cases, the physicists always use the term impulse. Impulse is force multiplied by, in linear motion, in linear motion, pulse of a force, impulse of a force equal to force multiplied by del t, the short interval of time during which it acted. In a cricket, maybe for 0.1 second. And in angular motion, in angular motion or angular velocity, angular impulse the is given by the angular momentum L multiplied by del t. Once again, you use the analogy because we have seen that force in linear motion is analogous to momentum in angular motion, right? This is also done. There is another part is deduction of moment of inertia of some regular shaped bodies. Like if it is a circular disc, or if it is a ring, or if it is a rod, these are the regular shaped bodies. These deductions of moment of inertia of these bodies are very simple, but let me warn you, it's very important for your examinations. In many examinations, they give you a problem to do the deduction. These deductions, you follow your textbooks. I'll not deduct here. Textbooks all are given. What I'll do, in your numerical exercises, there are some deductions they have asked for some peculiar shaped bodies. For those things, I'll give you the solution to those numerical problems. But for regular shaped bodies, you can easily follow your textbook. But of course, as I have been always telling, if any one of you face any problem or any doubt about any such deduction, just give a comment in the comment section of the channel. I'll give you that particular deduction. I have no problem, but I don't want to waste your time giving all those deductions because these deductions are pretty easy. Now, there are another point which is called couple. A couple. What is a couple? Couple is whenever you have a body, body can be any shape of a body, and you have an axis of rotation anywhere in the body, right? And say there are two forces of equal amount. This is the force F, and this force will try to bend the body or rotate the body in this direction, and this is another force F, which is the same force, and it will try to rotate it in this direction. This will also try to rotate it in counterclockwise, this also tries to rotate in counterclockwise. That means two equal forces working at two different points, and forces are in opposite direction. Forces are in opposite direction, and both these forces creates rotation in same direction. Then this whole feature is called a couple. And the effectivity of a couple is measured by moment of a couple. Say this distance is x, and say this distance is y, and say total length is t. The length of the rod, or you can say the total distance, perpendicular distance between the two forces. Then moment of the couple of the couple equal to sum of the moments of so moment of the force is one force is F into its moment is X, another force is F into its moment is Y. So this is equal to FD. That means any one force multiplied by the perpendicular distance. So this is actually moment of the couple is actually force multiplied by perpendicular distance between the two forces. This is called moment. In fact, I think here the your theoretical part of this chapter is over. I don't find anything more important. But if there can be a small nitty-gritties left out here and there, when we solve all the numerical problems, definitely something more may crop up, and we shall solve those issues at that time.